All right, for problem number 2, it's the revenge of the giant roller coaster with the idiotic spring at the end that stops you. So here we go. Now, let's actually run through our bar graphs. We did this in class, so I'm going to be a little quick about this. If you remember, at position A, we had EG. At B, we have a combination of kinetic and gravitational. Position C, it's all kinetic. And in position D, we actually have some all elastic energy because we're not moving and there's no gravity. Again, the clue that there's no dissipated is this word frictionless. So they ask us, how many joules of kinetic energy do we have at point B? And I was a little more obnoxious with this one. I wanted to give you a challenging problem because I was feeling sassy. So we have E gravity at A equals E gravity at B plus E kinetic at B. All I'm doing here is I'm taking the graph here and setting it equal to the graph here. So I know that I have 30,000 joules of gravitational energy at A because they tell me silly. And then we have 100 kilogram car, gravity's 10 and H is 5, plus E kinetic at B. And so what I get is that at position B, my kinetic energy is only 25,000 joules. Notice I didn't ask you for the speed at B. Could have, but I didn't. So you're actually done with part B. And then for part C, we want to know the compression of the spring. So it's the same trick. Gravitational energy equals elastic energy. Now I'm setting graph A equal to graph B. So I have 30,000 joules equals, and for elastic we have 1/2 kx squared. And we want to solve for x, that compression. If you ever wonder what a variable is, again, I have them labeled in the front with the formulas, so you'll know what things are. So we have 30,000 equals 1/2 times 600 times x squared, and that's going to be 30,000 equals 300 x squared. Let's do some grammar school. Let's cancel zeros. Meow. So we have 100 equals x squared. So our compression ends up being 10 meters of compression. What a coinky dink. All right, so that is the roller coaster problem. And we will take a look at our first momentum impulse problem in problem number 4.